Hello, everyone. Thanks for joining this session, the Art of Event-Driven Observability with OpenTelemetry. So my name is Henrik Rexed. I'm a cloud-native advocate at Dynatrace. And have you heard in the title, we're going to talk about OpenTelemetry. All right, so who I am. Very simple. My name is Henrik. As mentioned, I'm a cloud-native advocate, but prior to that, I've been focusing mainly on performance engineering. And because performance engineers is still in my heart, that's why I'm a producer of a YouTube channel called Perf Bytes, producing content for performance engineers. And I have another channel which I own where I try to build content for people who wants to get started in observability and know about observability topics. So it's called Is It Observable? So check it out. It's out there, it's free. And if you send me feedback, it's the best way of knowing how to improve my content. So check it out. All right, so what are we going to talk about during the next 25, 26 minutes or so? A couple of things. So obviously OpenTelemetry. So I don't know how much you know about OpenTelemetry. So I'm going to remind the various components involved in OpenTelemetry. And specifically, we're going to focus on traces and how to produce traces. And of course, it's ADA Summit, so we expect to see how can we produce traces in ADA architecture. You will see there's plenty of various options, so we can talk about that. And at the end, we'll see, of course, the value of span links. All right, so we have a lot of content to cover, so let's get started. So once upon a time, I was a kid, and I loved to draw and paint, and my grandma and my mother teach me how to handle brushes and pencils. And when I started my first job, a couple of years back, at that time, we have a couple of tool sets available. So 24 years ago, we have tools that were able to collect data points from our server. So perfmon, top on Unix, or nmon, where you had some values about how you're consuming the resources within our servers. So at that time, with the information that I had, I was able to draw, points. So I was able to draw this fantastic drawing reflecting the health of my web server. So that's web server health 1999. Then in 20 years ago, we had improved our toolings in that same organizations. So now the data was stored. So we have sort of a history of the data. We were adding some metadata due to the CMDB that we tried to implement in the environment. So at least the data points were connected. So I was able to make lines, and that's web server health. Now, we have a shape, at least we have something, but I did the best with the information I had at that time. Then 13 years ago, we have implemented APM. So for those who doesn't know what is APM, APM stands for Application Performance Monitoring, showing the health of a solution. And I was able to get some distributed traces because a couple of solutions out at that time were producing tracing. And we had metrics and so on. So now things were a bit more connected. So I was able to shape almost like eyes, a mouth, a noise on that server. So it was more reflecting what was the actual situation at that time. So web server health in 2010. 10 years ago, now, because we were producing so much logs from our proxy, from our web servers, from our applications, then I tried to parse those logs and attach it to the current information I had from the APM. So I had some information. It was a bit clearer, but still not better. I was able at least to draft the hands and the arm of my server, so that was actually better. But let me show you what I wanted to draw, in fact. That was the actual painting that I had in mind. I had the server wearing some clothes, so networking, some load balancers, and then the server was sitting in a park or in a landscape. So there are something surrounding the character. And I was not able to do that because I didn't have the right tool set. I didn't have the brushes. I only have one type of color. I didn't have one type of pencils. So I was pretty much limited. So how can we improve that? Well, let me introduce your artistic tools that you should use if you want to represent your current situations. And that is, if you understood well my what I was presenting, I was referring to monitoring. And now today you probably heard about the buzzword observability, and this is where we're heading to, where we're getting more information, where we understand a bit more, and then we are able to draw or paint properly, realistically, the environment. So for that, we are relying on pillars, so different information, to be able to understand precisely what is going on in environment. So logs, of course, we talked about it, very, very rich informations, events in cloud native environments like Kubernetes, it generates a lot of events, but there are plenty of other events like the deployments, the versions. If you track that, then you have the landscape of your character. The metrics, I'm not referring to the old-fashioned metrics. We need metadata on top of that. So this is also crucial. And of course, traces, we discussed about it. And then if you start from the traces, we need to go deep down in the code, and profiling will be the right answer. But if you just separate the storage of those signals in a separate data source, then you're not able to correlate. So this is, a lot of people is doing this. And we have to avoid doing that. But storing it in a central repository, it's fair. But if you don't add the context, then it doesn't make sense, because we want to link things together. So we need to add context up to that to be able to say which technology I'm using, which server, which services I'm referring to, which node, which deployment, which version, which geo, and so on. So there's plenty of context that we need to add to enrich, to be able to understand what is happening in this specific region or in this specific version. If you look at the observability landscape today, there are pretty much solutions that are either very specialized on everything that exists, there are a few of them out there, or there is pretty much specific tools for specific signals. So it doesn't help us in the markets to make sure that we are all storing everything in the same bucket and being able to collect that. So that's why I think observability is not a science, it's hard. We give you the tools, and you will have to paint and use the right toolings to be able to go to the right elements. And I think what the market is providing today is a standard, and that standard is OpenTelemetry. And let's jump into OpenTelemetry, and you'll see that OpenTelemetry is going to be the right tools, the right pencil for the next painting that you're going to deliver. So like mentioned, OpenTelemetry is a standard. So it's an API SDK that will produce telemetry signals out of the code. So you will have to add an agnostic library into your code, and you will be able to produce telemetry data out of the box. As of now, if you just look at how OpenTelemetry is currently configured, there is, in one end, the instrumentation. So close to your code, you'll produce metrics, logs, traces. And then when you play that instrument on the code, you will generate some sound, but you don't need a certain amplifier, but most of the time you need it. So that's why the collector comes in the picture, where you will send a sound to the amplifier, the collector, and you will be able to say, hey, I want to add some chorus, I want to add some override, I want to amplify it. The collector helps you to modify the data and amplify it to send to different destinations. As of now, if you look at the OpenTelemetry project, there are several pillars supported by the project. So traces is obviously stable as of now. Metrics is, for most of the languages, stable, except for two of them. Logs is, we should expect it in a few months. There are a few projects few languages that supports it, but let's wait 2 or 3 months again, and we will have a stable versions. Continuous profiling, the specification is still under construction, so we should expect it more in 2024. Now, how would we produce traces with OpenTelemetry? Where are there 2 ways of doing it? So first, there's the manual way. It could sound very expensive, where you decide what I want to trace, which piece I want to create spans. I will explain what is a span in your code. So you will have to do that from the code perspective. Or the other way around is doing auto instrumentations, where obviously it will auto instrument your code, so less expensive, but you'll see that auto instrumentations basically instrument well-known framework of the market. So if you're not using any framework of the market, then you may probably use manual. So usually you combine both of them, auto and manual instrumentations. When we talk about traces, since a couple of minutes now, traces at the end is a big JSON blob object where you will have some sub-steps of your transaction. So a trace is a transaction, and the sub-steps of your transaction is called spans. So at the end, it's a JSON object with a list of spans. And every span to attach to it has a context. A context is the trace, who I belong to, and the trace ID, which ID is my step. And then if I've been called by someone, a parent, I will attach my parent ID as well. To be able to create traces, we will have in our code to just add the OpenTelemetry API SDK. And if I want to create manually spans, I will need to create a trace provider and a trace propagator. Then in the trace provider, there's a couple of objects. I'm not going to describe all of them, but briefly, a span processor will basically adjust the way you're sending the data. Sampling is basically, we will talk about it in a few seconds. And then exporter is basically where do I send that temperature data? Usually we use the collector. And then resource, we will explain what it is. Once you have the trace provider, then you would be able to basically create spans, create a sub item of your transaction. So what is a resource? A resource at the end is the identity of your service, who you are. And then most of the observability solution of the market that will ingest OpenTelemetry will basically name the service that producing this telemetry data based on the resource. So that's why you have a semantic convention like the service name, the service namespace, the version, and so on. So we talked about sampling and why you will see why I'm referring to sampling, even if it's a bit detail on that step, because you will see that later on when we talked about the challenge with EDA tracing, sampling is quite important. So sampling is basically you decided what you want to send or what you want to drop in terms of data. Of course, everyone wants to send 100% of the temperature data, but it comes with a cost because that data will be stored somewhere. And usually we want to have a right balance between, I want to have the right observability with the right cost. So there is different sampling as of now. So now you are the one decided what you sampled, but the future will be better where the observability solution will control OpenTelemetry and adjust the sampling library. But as of now, you will have to rely on those sampling. So you have always on, which means 100%. Everything will be sent. Always off means 0%. You have parent base. Parent base will be accurate to use if you're a dependency. For example, service B, C, D, E, here is parent. I will only send trace spans involved in a transaction. So it avoid having the noise of the health checks, for example. You have the trace ID based ratio where you define some ratio on each of those services. And based on that ratio, we will drop or send the data. And then you have a combination of parent and the other. Parent based always on, parent based trace ID ratio, parent base always off, and so on. So what here in this example, I have service A defined in a trace ID ratio with 50%. Service B here, we have defined a parent-based trace ID ratio of 25%, and all the dependency will be defined with a parent-based trace ID ratio. So why do I talked about this? Because here, if I define this as an end user without any understanding on the sampling, if I have 1,000 requests coming in a given time frame, it means if I'm looking for an end-to-end trace to understand the full transaction between A to E, here with the sampling decision that I've defined here, I only have one request out of 1,000 that will have the details. So you see, depending on how you define it, you will lose details, and which means your painting will lose color, will lose precisions, and that's what we don't want. The other aspect is propagation I mentioned. So if I start a service A and I have a transaction going from A to B to C, when I start the traces at the service A, because it's the same service, it's very easy to keep the same context. So every time I do a sub-transactions, the context is passed through the functions. So then this is how we're linking everything. But how do I make sure that the context will be sent to the next call, service B? Well, this is called propagation, where before we send it, we inject the context, so trace ID and the span ID, the last call. And then the service B, the first thing it's doing, it's extracting the context to pass it to the rest of the flow of the transactions. So when it comes to HTTP, very easy, W3C trace context, handle it properly well. We don't have to deal with anything. It's done automatically. When it comes to event-driven architecture, depending on the technology, you don't have that. So usually you try to add as a header of your message, the trace, the context, or you add as a property of the message. So then you will have the first thing you will do on service B once you receive the message is extract that the context to then pass it to the rest of the tracing technique that you're doing in your code. So now we talked about this. So let's have a look at what we get when you have a traditional microservice architecture. So I have a microservice architecture, and if I have several dependencies, I can trace. So the advantage, I can keep track of all the different steps of a given transactions, and I will have a visualizations for the traces. And you here, I have an example of an HTTP GET methods on the front end, taking 25 milliseconds. And I can clearly see if I want to optimize that methods, I can see that the list recommendation takes about 20 milliseconds. So if I optimize this, then I will save some times. And then what I discover here is that get product is called quite often. So maybe I can reduce the number of calls on get product. So with that details, I can basically improve my versions of my applications. That's perfect. Yeah, you will say, yeah, okay, cool. But here we're talking about EDA, so event-driven architecture. What do you refer about microservices? I understood you. Don't worry. Don't worry. You will get to the main topic. So what about event-driven architecture? Well, I have the same application, taking some web services or microservices, and suddenly one of the applications sends a message to a queue or whatever it is. And then the queue after that there is several consumers that will be triggered. So doing their various stuff. Maybe one is just a batch. The other one is doing like some stuff on the financial piece of my transaction. I don't know. Let's take examples. But at the end, what we have here using this could be quite weird, because maybe I will have a trace of 6 minutes. Maybe if my EDA architecture is very fast, it is almost transparent. So what are the actual recommendation from the market? Well, let's see that. The first aspect is end-to-end trace. So we'll have an example. We'll cover the end-to-end trace, and then we'll see how can we improve it. So here I have a small prepared for this event, a GitHub repo with an example. So if you want to do this at home, you're free to do that. I'm really relying on Solas PubSub. I have an application with a publisher and a consumer. Aside of that, I have a real OpenTelemetry demo application doing just HTTP requests, so traditional microservice architecture. And here my intention is to show you the challenge. So let's start the demo. So here, first thing, the challenge of pushing the context I mentioned. So here I have I'm using PubSub, very simple. I have a couple of traces. You can see I have a start spans and so on. And at one given step where I'm sending the message, I want to basically extract my trace ID of that current transaction, the context at the end. And you can see here I'm adding to the message a property with those two informations. So then at the consumer side, I'm going to just show you one of the consumers, not all. I have the first thing that I'm doing when I receive the message, I'm extracting the context, the trace ID and the span ID, and then I'm creating a new context, and I'm basically saying that I'm starting a new span, and that span is basically part of the previous one. So I'm attaching my different details to my publisher. So we have a publisher, the consumers, and everything will be attached to an end-to-end trace. So what do we get if I'm doing this? Well, let me show you. If I take the first example, here I got a trace I've already ingested. So here I get my end-to-end trace. First of all, I'm very happy. Woo, that's exciting. I get my publisher. You can see that we have 123 milliseconds of timing. And that publisher has a couple of sub-steps, and I have no details because of the structure of the data. And the second aspect is that you can see we have the consumer. It takes almost 1 minute or so. And then the transaction. So at the end, I have the end-to-end trace. I'm super excited. But here, I'm losing the details. I'm not able to understand what is actually happening on the publisher because of the length of the trace. So in that particular case, on that particular examples, the way of utilizing the end-to-end trace doesn't make sense because I won't be efficient when I will need to troubleshoot. So how can we improve this? Well, let's see the second approach. The second approach is use span links. So here we are on the left side. So we had 120 seconds to black box. It was very short time frame. And then we have the consumer taking most of the time of our transactions. So very barely unusable. That's why OpenTelemetry introduced a notion of span links, where I have if I use span links, it will be different. I will have 3 traces in that case. One, the black box is a just unique trace. And then the consumers, they will be linked to my main trace. So the advantage is that I'm not polluting my publisher trace. and everyone has an individual trace. So same thing, let's go see that the details as an example. So here, if I'll go back to the folder, I have the same example. So I'm keep the publisher will be the same. The consumer will be slightly different. So I get the trace ID, the span ID. Here I'm getting a span context, and then here I'm creating a link. And when I start my first span here, I'm saying that I have a link and I'm attaching that to the link. So what would that mean in terms of representations? Very simple. If I go back to the UI of Dynatrace, I have another example where here I'm only showing you at the moment the publisher trace. You can see that the publisher, each publisher will have an individual trace. So I can see the details of where I'm spending to. And no, that's in the publisher. Oh, sorry, bad example. Yeah, by the way. And then I can have links somewhere. I have the example. I don't have it here. Let me check if. Never mind. So at the end, we have a link attached to the consumer. And here you can see there's a tab links, and I'm able to go back to the publisher. So both traces are linked. I will have the publisher advantage is that this trace here, we can see that we have 120 milliseconds trace. I can understand where I'm spending my time. So it's much easier to troubleshoot the publisher itself. And then I will have a separate, of course, trace for each consumer. So that's the advantage for, in my case, in this particular design, it makes more sense to use that approach of separating and linking the traces together. So at the end, what I'm meaning here is that observability is not a science, it's an art. You will have to manage your pencils, your brushes, and figure out which type of design should I use, depending on how my application has been designed. So either the end-to-end trace will make sense for you, or either the other one with the links will be better. So the pros and cons, let's talk about this pros and cons of span links. So if I use span links first, I can keep track on my consumers, have more details on my publisher. I can visualize properly each individual traces one by one. The cons, first of all, the relation between the consumer and from the consumer to the publisher is very easy. So I can easily click from the consumer to publisher. So that's fair enough. But the opposites, from the publisher to the consumer, it's more difficult. So here there's somehow a disadvantage. The last disadvantage is sampling. I have two traces, consumer, publisher, and then if there is a sampling, let's say I have a link from the consumer, but suddenly the trace from the publisher has been sampled, which means no details anymore. So there's always the pros and cons. Again, you have to measure them and figure out what will be the best for your architecture. So at the end, as a takeaway, first of all, make sure your code is agnostic by using OpenTelemetry, so you can basically start customizing your OpenTelemetry data. So observability, make sure to produce traces, make sure to add the right trace context, add more span attributes, and then be creative. Understand your systems, understand the toolings that you have in your hands, and design the right observability based on your application. So you are the artist. Take the tools and design the right observability. As a short teaser, is it observable? It's out there. A lot of content about tracing, SLI, SLO, logs, trace, whatever. Check it out. It's out there. I need feedback. So just check it out. Send me your feedback, and I will be very happy to improve the content that I'm producing. Thanks for watching, and see you soon in Q&A.